So till now, you have studied all the concepts related to machine learning. You have understand regression, classification, clustering. You have done with the NLP techniques. So now it's time to practice your skills, right? So for the purpose of that, welcome to the first machine learning project that you will be solving. Okay, so this project is basically related to Titanic ship and it's been given on Kaggle. So I'll be explaining you all the concepts, that is how to deal with the data, how to analyze your data, and how to predict things. Well, in this particular challenge, we are given with the data of Titanic ship, and you all must be knowing that this ship met with an accident. It collided with an iceberg, and due to the lack of lifeboats for the passengers, so much of the people died, right? And mostly women, children, and upper class survived. So in this challenge, they have given us a data, and the target is to predict whether based on the different scenarios or different parameters, can you predict that if this particular person survived or not, right? So we are given different parameters for a person, that it belongs to this class or this cabin, it was fair, like that. And you have to predict using these parameters that whether that particular person survived or not. Okay, as simple as that. But the data you have to deal is little bit complicated, and it's a real data, so you must be excited to solve this particular challenge. Okay, so let me explain you the data in this particular lecture. So we have these particular parameters. Okay, so survival parameter means whether the person survived or not. So 0 means no and 1 means yes. P class, that is the class to which that particular person belongs. That suppose we say that he belongs to economic class, or he has taken a business class ticket. Like this, there were tickets in the Titanic ship also. Then the sex, whether the person was male or female. Age of that person. SIBSP means number of siblings. Parch means number of parents. Like a person was with a father or a mother or both, like that. Ticket, the ticket number of that particular person. Fare, the passenger fare, right? So if you are traveling in a plane, then based on the price, you can tell that whether that person belongs to economic class or a business class. Similarly, in case of the Titanic ship also, using the fare, we can make some analysis. Cabin, that is the cabin number of that particular person. Embarked means the port of embarkation, that from which port that person took the ship. So we have 3 different embarkments, that is C for Cherbourg, Q for Queenstown, S for Southampton, right? So these are the parameters involved in this particular data, and we have to deal with it. So first of all, we'll import our libraries. So I have already imported these libraries. Okay, I have written it, and we'll be classifying our data. So I have already imported the classifiers over here. Okay, and we have used pandas, numpy, matplotlib, cbun for the visualization purpose. Then we have used scikit-learn to get our models so as to train them and to predict our challenge. Okay, so now I'm loading the data. So data equals to, as we are doing in all the previous videos, read CSV. Okay, and then I'll give the path as per my system. Users Dell desktop, and the name of my data set. So the name of my data set is Titanic data.csv. Okay, actually there was a space in this, so here we have our data with us. Okay, now let's print the first 10 entries of this data. Okay, so these are the parameters. Passenger ID, whether that person survived or not. P class, name, sex, age, SIBSP, parch, ticket, fare, cabinet, embarkment. Right? So in this data, we have different type of features. Number 1, categorical. So sex and the embarkments are in categorical form, right? Because these are the strings given to us. Then we have continuous data. As in case of age, and fair, that's a decimal, that's in a decimal form. These are not discrete values, so that's a continuous data. Then the discrete data, SIBSP, parch, these are only some values. Suppose what discrete and what continuous means is, suppose I'm saying that I have only entries like 1, 2, 3, 4, right? So whatever the data will be, the parameter will be only in the form either 1, either 2, either 3, or either 4. So that's we say as discrete. But if we say that a data can, parameter value can be in the range 0 to 100, it can be any value. So that means we have a continuous data given in a range. And then the alphanumeric, as in case of cabins, because we have int as well as alphabets also. So C85, it's a alphanumeric form. So we have to deal with these features. Okay. Now let's check the data info. So now you can see that we have total of 891 entries in our data, and some of these entries are less in number. That means we'll be having a null values over here. So we have to pre-process our data also before training our machine learning models. Let's check the null values first. Data dot, for that I have already shown you in previous lectures. So similarly, data dot is null. I'm asking that whether the data is null values. If I'll print it, it will give the index values where I have the null values. And if I print dot, if I use dot sum, then it will total the number of null values I have. So it's saying that in case of age we have 177 null values, in case of cabin we have 687 null values. Okay, and in case of embarked we have 2 null values. Okay, so let's check the data dot describe. It will give us a data description of the stats. Okay, so it has given us the description of data parameters. Those were in numeric form, right? So you can clearly see the distribution of each parameter. Okay, so this was all for this lecture. We have understood the data and we have learned some stats and the null values we have, whether we need a pre-processing or not. Yes, we need a pre-processing. And in the next coming lecture, we'll be analyzing our data so as to see that which parameters plays an important role to predict this challenge. We'll be analyzing our data. Till now, I have shown you how the data is, what are the parameters and what data actually means. So now we'll be analyzing our data, that what parameters are really important to predict the values. Okay. So for that, I'll be preparing a heat map so that we can see the correlation between the parameters and the output. Okay. So the output we have is survived. And the rest of these parameters that we have in numeric forms are we gonna use in as an input. Okay, so let's start with the code. So we'll be plotting the heat map. For that I'll say okay, so for that what I'll do is I'll use C1 library and then I'll use heat map. Okay, now we have to pass on the data. So we have named our data as data only, and the parameters we have to select. So these are all our parameters that we have in described column. Okay, so we'll be using all these parameters in here. So parameters are survived because we need to compare it with others. So let it be on the top, then SIBSP, then parch. Okay, I've done a mistake. We have to mention it in a inverted commas. Okay, so parch and then age. Okay, and then the fair. Okay, cool. Also, we want the correlation, so it's basically the correlation of it. And yes, we want the annotations, that is the graph over. I'll show you. You will get a graph. Okay, first of all, let's print this one only. Okay. So yeah, here it is. If you set annotations as true, then you will be getting the decimal values also. That is the value of the correlations as well, which is easy to understand. Okay. So and not equals to true. right? So here we go. You can see that now we have the decimal values in the form of a matrix. In the color matrix, we have different values. These are the values of correlation. That is, now let's see. We have this particular survived over here. Now survived and survived. It's very clear that a column will be 100% correlated to itself, right? So survive is 100% correlated to survive. SIB-SP is 100% correlated to SIB. Now you see, what we'll do is, we'll compare the survived column with the rest of the parameters because that's the output, okay? And you can also see that it has given us a color scheme. The more lighter it is, the more correlated the value is, okay? Now, let's compare the survived with SIB-SP. When you are comparing survived with SIB-SP, you are getting this particular correlation value, that is minus 0.035. That is, it means that it's not correlated. Then Parch, it is 0.082, very less correlation. Then Age, it's again a negative correlation. Then Fair. Now, the fair means that the more the fair is, the more are the chances of the survival, because it's the most significantly correlated value comparing to all rest parameters, right? So fair is 0.26, having a value of 0.26 correlation value with compared to the parameter survived. Okay, so the conclusion is, I have written it over here, only fair feature seems to have significant correlation with the survival probability, but it doesn't mean that other features are not useful. Because there might be a thing that when we are comparing, that when we are combining these parameters, they hold the importance, or when we are taking a sample of a parameter, then it might be holding a importance. So this will be discovering one by one when we'll be discussing about these features in detail. Okay, so for now, what I'm telling is, this is a heat map and it's a very good way to find the correlation between your parameters. Okay, so now we'll understand the parameters SIB-SP. Okay, so what was basically SIB-SP? SIB-SP is given over here. I have told you it is the number of siblings and it's having the value like 1, 1, 0, something like that. Okay, so these are the number of siblings that a person has in that particular ship. Okay, so now we'll be talking about this parameter only. So for that, what I'm doing is, let's find the unique values that we have in SIB-SP. So because it's a discrete data, so you can easily find out those values. So SIB-SP, right? And then what we want is, we want the unique values in it. So the unique values are 1, 0, 3, 4, 2, 5, 8. That means either a person has one sibling, 0 sibling, 3 siblings, 4 siblings, 2 siblings, 5 siblings, or 8 siblings. There are no any other value irrespective of these ones, except these ones. Okay, so now what we'll do is, we'll basically plot this surviving probability with respect to SIB-SP. Okay, so let's prepare a bar graph. So bar graph, and name it as bar graph SIB-SP because it will be easy to understand for you guys. Again, we are using Seaborn library, and to plot this we are using a factor plot. Okay, and now we have to mention the data we want. So the X label will be the SIB-SP value, that is the input, and the output Y will be the survived probability, which is named as survived in our data. And we have to mention the data. So data equals to data. Sorry. And then we have to mention what kind of graph we want. So we need a bar graph. So we'll say kind equal to bar, right? And then the size of the bar graph, the bars we have. So let's say it be 8. I'm randomly taking this value because I have an estimation of how this graph will look. Okay, you can do a hit trial over it. And then what I'll say is, I'll set the labels with me. Okay, So what I'll do is I'll use, okay, first of all let's print it. So you can see that these are the values we have in our bar graph. When we are having one sibling only, then we are having maximum chance of survival. And from this particular graph, you can see that the more number of siblings we have, the lesser the chances to survive, right? So the conclusion we can draw is that passengers have a lot of siblings. Passengers which are having a lot of siblings have a less chance to survive, and the person with 0, 1 or 2, I'll say 1 or 2, have more chance to survive. Okay, so this was our conclusion with respect to the SIBSP. That is, if we are having a single sibling or two siblings, then we are having a good chance of survival, or let's say then those persons have the good chance of survival. But as the number of siblings increased, the chances to survive decreases. Okay. Now let's talk about the age. So for that, what I'll do is I'll again use a factor grid, but now I'll be showing you a bar graph with the graph over it, so you can see the abrupt changes in these values. Okay, so I'll be making a graph so as to see the distribution of age with respect to the output parameters, that is the survival probability of the passengers. So for that, I'll be using the C1 and facet grid so that we can see the distribution, that is the bar distribution, and the graph embedded over it. So for that, let's name it as age visualize. Okay, and then we'll use C1 that we have already imported as SNS, and I am be using phase grid, right? And then we have to mention the data. So the data is named as data only, and then the column that we are talking about. So we are talking about column survived, and then the size. So let's say the size be 8 or 7. So let's be 7 only. Okay, and then I want to plot, so I'll say age visual equals to age visual dot map, and what I want to map is I want to draw a displot over it. That is, what I'm doing is I'm preparing a facet grid for the survived parameter, and then I'm building up a distribution of age over it. So for that, I'll use again SNS, and then I'll use displot. Okay, and we have to mention the data that we are wanting. So the data is age. Okay, so sorry, I have done a spelling mistake. Okay, so age visual equals to, and now I'll be setting my labels as Y label as survival probability so that you can understand it quite clearly. So you can set it like age visual dot set Y labels. Okay, so what Y label you want to set is, I want to set it as survive probability. Okay, so survival probability. Okay, it won't make a much difference. Irrespective of using this code, you will having simply survive written it over here, but you can specifically mention the labels that you want for your graph. So I have done a mistake over here. It's D. This two. So yeah, here we go. Now that's the graph of the person who failed to survive, who couldn't survive, and that's the graph for this person who survived. So you can see that it's basically a Gaussian distribution, right? It's a kind of Gaussian distribution, and the thing is that the age distribution is different in both cases, that is the survived ones and not survived population. But you can see that there is a peak corresponding to the young passengers, right? In case of the survived one, that there is a peak corresponds to the young passengers, and the passengers who survived 60 to 80, less than 60 to 80 have survived. So even if age is not correlated with the survived ones, we can see that there is an age category of passengers, right? So the more I think the age is, the chances will be less to survive. And you can see that the young persons have more chance to survive, right? So this was the conclusion when we are discussing about age with respect to the survival probability. So now we'll talking about the survival probability with respect to the gender a passenger has, that is a male or a female, what chances they had being survived. Okay, so or is there any probability that, or is there any correlation between the sex of a person and the survival probability? We'll just check. Okay, so let's talk about it. What we'll do is, for that we'll simply use the matplotlib and we'll be plotting a bar graph for that, and we'll see the comparison of the survival probability. Okay, so for that we'll simply say import matplotlib dot pyplot as plt, right? And then we'll set, okay, and then what we'll want is, we want our 6 plot, right? And we'll use the Seaborn library. Okay, so let's not use the matplot, let's use the Seaborn library, and I'll be using a bar plot for that. I kind of love Seaborn more than matplotlib because it's having very good resolutions of the images of the graphs, and it's more advanced over matplotlib. You can get some complex graphs, complex visualizations in a very detailed manner using Seaborn library. So yeah, that's why I use Seaborn. Okay, and now we have to set our data, the input and output, and the data we are using. So x is the input, y is the output, and the data. So data equals to data, right? The output is the survived probability, so it's survived only. And then we have to set our input. So input is 6. Okay, so here it is. Okay, so now you can, okay, let me set the size of the graph, it's getting too much bigger. So for that, let's say plt dot figure, and then the figure size, so fig size equals to, let it be 12, 10. So here's the graph. So now you can see that it's quite obvious. Okay, let me do one more thing. Okay, let's say data, I'll print this values 6, survived, okay, dot group by with respect to the 6, and I want the mean of it. So here you go. Now you can clearly see that the men has very less chance to survive over females. So sex has a very important role in predicting whether the person will survive or not. And for those who have seen the movie, you can clearly remember that everyone was saying at the time of rescue that women and children first. So you can see that the one that we have seen in the movie and the data we have and the values we are getting, it's all matching with each other. So that's a very good indication that yes, we are doing it in a right manner. So as in a graph, you can see that females have the very high probability to survive, and I have shown you with the figures also that what I have done is I have used these two columns, sex and survived. I have grouped it with respect to the sex, and then I have calculated the mean of it. So 18, let's say 19% of this value was the male and 75% of this value was female. So the females have a very high chance to survive over males, right? So now we'll be talking about the P class. As we have already seen what the P class is, that is, okay, let me show you. So the P class, that is the ticket class a person has. First class, second class or third class. So whether a person has a chance of higher survival based on the class it has. So whether a first class person has more survival probability with respect to the second class person. So we'll see with the help of a graph. Let's name it as P class only, and I'll again use SNS, Seaborn and vector plot. Now we have to mention the data. So the input is P class, and then the output is survived. Then we have data equals to data, and the kind of data we have. So the kind of data is bar graph. Okay, and let's set the size V8 as we have done already in previous cases. Okay, so here it is. Now you can clearly see that the higher the class of your ticket is, the higher the class the passenger has taken, it has the more chance to survive over others. So a first class passenger has a more chance to survive over second and third, and similarly the second class passenger has more chance of survival with respect to the third class passenger. So that's the intuition based on the class of a passenger. Now we'll be talking about P class versus survived with respect to the sex. That is what I'm saying is that will be visualizing that the effect of a passenger class with respect to the survival probability taking sex into consideration. Okay, so for that let's plot a graph. Let's name it as anything, A equals to and SNS dot vector plot. Then we have to mention the data we want. So the data is P class, right? Then the output. So the output is survived, right? And then what I want is I want to plot P class with respect to survive taking sex into consideration. So for that I'll be using the parameter hue and then mentioning it as sex, and then the data equals to data, right? And similarly size equals to 7, and the kind of graph I want is bar graph. Simple and easy. So here we go, you can see that that's the graph, and now we have what we have done is we have plotted P class with respect to the survival probability, and the more and still the chances of the survival depends on the class we have. So the first class passengers have higher chances to survive, but when we are taking a single class into consideration, then you can see that in each class females have a very much higher chance with respect to the male passengers, but taking the population in total, the passengers having the higher class have higher chances of survival, and a female having a higher class will have the higher chances to survive even over the rest of the classes and the males irrespective of the class. So that's the intuition that we can build up using this graph. And now we'll be visualizing the effect of embarkment with respect to the survival probability. Okay, so for that, first of all, let's understand it. Data embarked is null dot sum. So we have only two null values in it. Now let's count the each value distribution. Okay, so these are the three classes S, C, Q, and we have 644 passengers embarking from S station, 168 from C station, 77 from Q station, right? And let's fill up the empty data with the most frequent of this. So what I'm saying is data, let me copy it. So data embarked equals to data embarked dot fill NA, and I am filling up these two null values with S because these are the most frequent values. So if we fill up these two values with respect to S, it will not hamper our distribution much. Okay. So now we have no null values in the embarkment column, and it's time to plot. So let's say SNS, again using the factor plot. Same thing to do. Mentioning the input. Input is the embarked. Copy, then again paste. Let's copy the rest of the code from here. Right? Survive. Why the output is survived? Yes. Good. Now we don't want any correlation, so data equals to data, size equals to 7, kind equals to bar. We are ready to go. So that's our graph. So you can clearly see that the passengers coming from the C station has the more chance of survival over the rest of the passengers. So what do you think might be the chance of a person embarking from C station to survive over the others? Right? So I have a reason for that also. Let's understand it. What I'll be doing is I'll be plotting the class with respect to the embarkment. Okay, just wait a second. So what I'm saying is, again plotting a factor plot, right? And now I'll be plotting a factor class for P class, and the columns be the embarked, right? And then the data is data, size equals to 7, kind equals to count. Okay, and now let's plot it. So you can see that we have different classes with respect to the embarkment, and now in case of the persons who embarked from the C station, you can see that majority of them were in first class, but those who embarked from S, the majority were in third class. Similarly, in case of embarked, the majority were in third class. So we have a higher chance of survival when a passenger survived from the C class. So that's why the passengers, those who survived from C class, survived because they have most of them belonging to first class. There were less passengers belonging to third class, so their proportion was high. So the passengers from C stations are mostly in the first class, which have the higher survival rate, right? And these persons from S and Q stations were mostly in third class. So that's the reason, and that's the reason why we are getting up this kind of graph. So this was all for the understanding of parameters and their correlation with respect to the output survive. So I think we are good to move with our data. We have a knowledge about the parameters and their correlations. We have analyzed that how the parameters are functioning and how they can be functioned if we combine them. And till now we have understood the data and we have analyzed the parameters with respect to the output. Now we'll be preparing our data for finally using that data for the training of our models. Okay, so first of all, let's load the data. I've already copied it. So that's our data, training data. Let's check the data. So here it is. Okay, now the data info. So now you can see that we have some missing values over here. In case of cabin, in case of age, these are the missing values that we have, and we have to deal with all these missing values. Okay, So first of all, let's find the mean of the age data. So data age dot mean, then standard deviation equals to data age dot standard deviation. Okay, so that's the mean and standard deviation. Let me print it for you. It's the mean, and that's the standard deviation of our age column of our data. And let's check the total number of null value that we have in our data. Let's name it is null equals to data age dot is null dot sum. Okay, let's check it. So we have 177 of null values in our age column, right? And now what I'll do is I'll find out a random value between the range mean plus minus standard deviation. Okay, so what I'm saying is, let's say random age equals to, because I want my parameter to be having the same distribution as it has. So to maintain that distribution, I'll be randomly fitting values in place of those null values in the range mean plus minus standard deviation. So it won't be hampering our distribution, and also we will resolve the issue of null values. So for that, np dot random dot rand int, and then the values mean minus std, then mean plus std, and then size equals to the total values we have in null values. So sizes is null, that is 177 values we want in this particular range, mean minus standard deviation and mean plus standard deviation. In this range we randomly want 177 values. Okay, and then what I'll do is I'll fit this null this randomly arranged random ages in place of the null values we have. So let's do it. Let's name that data as age slice equals to data age dot copy. So I'll be having the same data in age slice, and now what I'll do is I'll say age slice then the null values it has age slice. What I'm saying is I'm saying the null values of age slice in age slice, that is what it will give us. It will give us the indexed values of the entries where we have null values. So we have, so now what we'll say that age slice, and it will have numbers. So in place of these numbers put the random age. So the index values where we'll be having null values, we will fit in the random ages over there, right? And then data age equals to age slice, right? Okay, wait a second, we have to use square brackets. So yes, we are done. Now let's again check it. So now you can see that we have no null values in our data, and if I'll check the data info, you will see that it has all the entries filled up. So you can see that now we have 891 entries over here, right? It's as simple as that. And now in case of embarked, we have some entries less. We have 2 entries less. So we have seen over in the previous lecture that the most frequent embarkment is the S embarkment. So we'll simply fit in that embarkment over here, right? So the data is named as embarked, and I want data embarked dot fill in with respect to S. Cool. So again, let's check the data info. So you can see that it's now filled up, and now there are some parameters that we don't want while training our models, because they are not giving us any concrete information. Suppose passenger ID or a cabin number or ticket number, that has nothing to do with the prediction whether they survived or not, right? So we can drop these kind of parameters from our data because they won't hold any importance while predicting the outcome. They have no correlation with the survival probability. That's what I'm saying. So that's why we can easily drop those columns. It will make our task easy to do the further processing. Okay, so for that, let's find out those columns. So let's say columns to drop. Okay, so which columns to drop? First of all, so first of all, the passenger ID. Whatever the passenger ID be, we have nothing to do with it. We can work using whether the person has first class ticket, second class ticket, the embarkment, the age. That's important. The passenger ID is not important. Okay, passenger ID. Then the cabin number, it's also not important. Then the name of the person, it's also not important because we are given a parameter gender, so we can find out it's male or it's female. And the ticket number, it's also not important because we can easily find the class of the ticket it has. Okay, and now we have these columns. We want these 4 columns to be dropped from our data, so we'll say data dot drop, and what we want to drop, these columns. So the column names is columns to drop, and then I'll say that I want to drop the column. So I have mentioned the x is equals to 1, and yes, keeping the indexes in place. So I'll say in place equals to true. So here we go. Let's check the data. So data dot head. So now we are left with these parameters: P class, sex, age, SIBSP, parch, fare, and embarked. And the output parameter that we are dealing is survived. Okay, so far so good. And now you can see that we have sex parameter as a categorical form. So we'll be converting this categorical to a numeric form. Okay, and similarly in case of embarkment, we have a categorical data, and we're doing the same thing when we have to convert that categorical data to a numeric form. So for now, let's do it. Let's prepare genders. Okay, so I am fitting up the corresponding labels with respect to I am fitting up the corresponding numerical values with respect to the labels we have. So the label first label is male, right? So with respect to male, I am saying 0, and with respect to females, I am saying 1. And now what I'll do is I'll say data sex parameter equals to data sex parameter, and I want it to map with respect to the genders. So where we have male, it will be mapped as 0, and where we have female, it will be mapped as 1. As simple as that. Again, checking the data head. So data dot head 10. Okay, so now you can see that in place of males we have 0, and in place of female we have 1. Don't worry, it won't be having any bias over here. Okay, and similarly we will do with the embarkments, right? So let's name it as ports equals to so we have S over here, S as 0, C as 1, and then Q as 2. Okay, and then data embarked equals to data embarked dot map the ports. So we are done. Let's check the data. So now you can see that the entire data we have is in numeric form and we are good to go with this data. And now we'll be splitting our data for feeding it to the machine learning models. Okay, so for that it's simple. The data looks like this and we have to use this column as output and the rest of the column for the input. So I'll simply use x equals to data dot drop data dot columns 0th column, that is the survived one, and I want the entire column, so x is equals to 1. And similarly the output will be data and survived parameter, right? So let's check it, x dot head, so that's our input, and y dot head is the output. And now I'll be splitting it. So for splitting I am using train test split method. So from sklearn dot cross validation import train test split, right? And then xtrain xtest ytrain ytest equals to train test split. Data is input is x, output is y. Let's set the test size equals to 30-70 ratio equals to 0.30. Then random state equals to 0, right? So here we go, we have split our data, the input and output data into 4 components, xtrain, xtest, ytrain, ytest. And now what we'll do is we'll feature scale our data, right? Because these values are in different ranges, so we have to feature scale this data so that our model won't go biased for any of this. So for that, what I'll use standard scalar, and from sklearn dot pre-processing import standard scalar scx equals to standard scalar, and then we'll transform xtrain equals to scx dot fit transform xtrain, and xtest equals to scx dot transform. So now what we have done is we have fit our data as per the xtrain, and then we are converting the xtrain as well as the xtest using it, right? So xtest, okay, it's giving error. Okay, I've done a spelling mistake over here. So here we go, we are done with our scaling the data. So now our data is scaled and ready for feeding it to our machine learning models for further training. Doing our final part, that is, we'll be training our machine learning models and we'll be predicting the survival probability of the passengers. So for that, we have to introduce our models. I have already imported the libraries, as you can see in the beginning of our course, right? So these are the libraries. We'll be using random forest classifier, logistic regression, KNN, decision tree, and support vector classifier. Okay, so using these models, we'll be comparing the results of the prediction. Fine. And now it's time to build our models. So let's initiate. So first of all, logistic regression, let's name it as logreg, and then logistic regression. Okay, then we have support vector classifier, so SVC classifier equals to SVC. Then we have decision tree classifier, so decision tree classifier, and then KNN classifier. So for that we have K neighbors classifier. So let's set the minimum points to be 5. Then we have random forest classifier, right, which is random forest classifier, right? And for random forest classifier we have to set the number of estimators, so that is the number of n samples we want. So n estimators equals to 1000. Then the criteria we are choosing for doing so is entropy, and we have to set the random state as well. Okay, so that's, we have prepared the model and now it's loading it themselves. So wait for it. Okay, it's giving an error in case of random forest. Let me check it. I have to use criterion. Okay. So here we go. We have initialized our models. Now we'll be fitting the dataset in these models. So copying each of this model. Now what we'll do is we will fit our data. So it's X train, Y train, right? So copying it, and okay, so the model is getting trained over the data sets we have, and now using this we'll be okay, the training part is done, and now we'll be predicting the results. Okay, so for that let's name it as predict. Okay, and then we'll say logreg dot predict, and we'll be predicting the X test value, right? Let's copy it. So this is how we predict our values. So the prediction results we have with us, and now we'll be finding the accuracy score of these models. So for that we'll use scikit-learn. So from sklearn dot matrices import accuracy score. So for that what we'll do is we can directly print the results over here. So accuracy score, wait a second, accuracy score, right? And so initializing accuracy score and then passing on the values we have, so actual Y test values, and we'll be comparing it with the log predict values, logistic regression, right? So it's here. Let me copy this again. So these are the accuracy results. So you can see that this one, that is the KNN classifier, is doing a very good job. We are getting a maximum accuracy of 82%, which is quite good with respect to this data, because we were having less data entries. You can check it, we have only 891 data entries. So to make such a good accurate score based on this data is very important. So in spite of having less data, we successfully managed to attain a accuracy above 80%. So this was all about Titanic classification problem. This is the challenge given over Kaggle. You guys can practice it over there. You can find out your predictions and can submit it over that platform and compete with the data scientists all over the world. In this particular competition or challenge, you have seen about the data we have, you have understood your data, you have analyzed your data, then you have prepared your data so as to feed it to the machine learning models. And finally, you are training your machine learning models and predicting the results with an accuracy of 82%. So guys, this was the Titanic classification challenge. Thanks for watching this lecture. Keep following. Best of luck.